In this lab, we'll be analyzing the response of an RC circuit. Let's start by simulating one in MATLAB. Here we have our two resistors, and let's simulate the response using this exponential equation. If we run the MATLAB code, we'll find that our response will look something like this. Here we have our 100k ohm resistor and our 10k ohm resistor, and we'll expect something similar when we run our circuit. This is the RC circuit. Power is supplied by the digital pin 2. We have a 10k resistor and a 100k resistor, and we can switch between them by moving these green wires around. We have a 10 microfarad capacitor which is attached to ground, and on the positive terminal we have a signal that enters pin A2. This is the code for the Arduino. Here we have our values for our resistor and our capacitor, and these affect our time constant tau. In the setup loop, we'll start by discharging the capacitor for 5 seconds. Then we'll write a high value to digital pin 2. In the loop, we'll read the capacitor voltage using analog pin 1. We have an if statement here to decide whether or not our Vin should be set to 0 or high. We'll use the if statement to switch our Vin whenever the loop iterates 500 times, or 10 times tau. We'll delay the loop by tau times 0.02 or tau over 50, and we'll scale it by 1000 so that it's in seconds. Our Vin will be 1024 when it's high, for reasons that we'll talk about later when we go into the processing code. So opening the serial monitor, we'll start to see what our output looks like, and this is the data that will feed into processing. As you can see, on the right side we have our values from the capacitor, and on our left side we have our Vin, which oscillates between 0 and 1024. Here's our processing code. In our draw loop, this first chunk draws the lines that measure each voltage. The next chunk of code labels each line with a voltage. Our last chunk of code gives us our key, which is given by two different colored ellipses, accompanied by text describing what each ellipse indicates. This code takes the values from our Arduino serial window and converts it to values we'll use to chart the voltages for our Vin and our V capacitor. These values are scaled by 1024, which is the ADC code for 10-bit data. This is also the reason why our V input is scaled by 1024. Running our processing code, we see the lines that denote our voltages, as well as the labels for each line. The green line represents our Vout, and our red line represents our Vin, and these are both labeled in our key. We'll now take the values taken from our processing code and plot them using MATLAB. If we zoom in, we can see that a lot of the features of this curve match the simulation we ran earlier. In red is our capacitor response, and in blue is our input from our digital pin. The last part of this lab asks us to change the y-axis to reflect voltage instead of ADC code. We can do that by scaling the values as they come in. We'll scale down by 512, coming from the processing code, and we'll scale up by 5. We'll also want to adjust our y label, and change it from ADC label to voltage. When we run the code, we'll see that our y label now reflects our voltage from 0 to 5.